No.
No. In solution. So whenever I say in solution, I mean is in water, basically, right? For the most part. So ionic and covalent compounds act differently in water. Ionic compounds will break up into separate ions. Let's write that down. Can you guys see this marker?
No.
No. So ionic compounds separate into individual ions. In water. So remember, solution doesn't always have to have water as a solvent, but in this class it's always going to be water, so I use water and solution interchangeably. So what happens is, let's say you take, let's say it's table salt, NaCl, and you put it into water. I'm going to put H2O on top of the arrow, just to indicate that it's in water. What will happen is it'll separate into a sodium ion and a chloride ion. So they just break up into pieces. And so however many ions there are in that compound, that's how many we break up into. The reason this is important is sometimes the number of particles matter. When we're talking about how boiling points and freezing points change, which we're going to do the next couple days, that matters. So when I put an ionic compound into solution, if I have 1 mole of this stuff, I'm going to end up with 2 moles of particles. 1 mole of sodium and 1 mole of chloride. So that's why this matters. Covalent compounds don't. It's pretty simple. They just stick together. Because they have covalent bonds, they're not going to separate in water because those covalent bonds are harder to break apart. Now remember, when we're doing this today, you need to know if the compound is ionic or covalent. How do we know that? Ionic, made of has an F in it, a metal and non-metal. Anybody forgets how to tell what's a metal and what's a non-metal? On page 158, there's a periodic table broken up into metals and non-metals. Covalent to non-metals. Or more, it could be 3 non-metals and 4 or whatever, right? And if it's all non-metals, it's going to be covalent for the most part, and if it's a metal and 1 or more non-metals, it'll be ionic. All right. Can I erase this side? Do we have this?
Yep.
So I'm going to make a little table here to show you what I want to do today. Let's do 1, 2, 3, 4. First category will be solutes. That's the stuff, right? The salt or the sugar or whatever it is we're dumping into the water. That's the solute. This will be moles of solute. I guess I could put N for that. And that's before we dump it in water, so put dry here. Make sure you understand that. And is it ionic or covalent? And then moles of particles. This is like in water, right? In water, not just water. There we go. Okay, so let's take a look at something like, let's say something covalent, like C6, H12, O6. So this could be like a lot of different sugars. It could be glucose or fructose or lactose or whatever. All 3 are nonmetals, so this is covalent. So let's say I take 1 mole of this and I mix it into water. How many particles am I going to have? I'm going to have 1 mole. Because it's covalent, so they're not going to break up into a larger number of particles. So that's pretty simple and straightforward. Now let's say I had something like sodium fluoride. It's in mouthwash, things like that, right? Let's say I have a mole of this. What is that? It's ionic, right? Sodium's a metal, fluorine's a non-metal. And so if I mix that into water, what am I going to get? I get 2 moles of ions. You get 1 mole of sodium, 1 mole of fluoride ions, so that's 2. Now it doesn't always have to be 2, right? Let's say I had magnesium chloride, okay? And I put 1 mole of this in the solution. Now magnesium's a metal, chlorine's a non-metal, so this is ionic. But how many particles are in that formula? There's 3. There's 1 magnesium, there's 2 chlorines. So if I put 1 mole of this in the water, it's going to break up into 3 moles of particles. It'll be 1 mole of magnesium ions and 2 moles of chloride ions, right? Cl2. So that's 3. Question so far? Question. All right. Not much. Multiply by 2, multiply by 3. All right, let's say I got 5 moles of this stuff here, right? First off, what is that, ionic or covalent? Covalent, right? Usually if you see carbon and some other stuff, it's usually going to be covalent. And so, how many am I going to have here? 5. However many moles of stuff I put in, that's how many moles of particles I'm going to have, because they all stay in one piece. They don't break up into one piece. So covalent, how many moles I put in, so many moles of particles there are.
So that's for covalent?
That's for covalent.
The same numbers?
Always the same number. For ionic, let's say it was, say I had potassium bromide, right? Let's say I put 5 moles of this into water. Potassium's a metal, bromine's a non-metal, so it's ionic. So how many moles am I going to end up with? 10, right? 5 moles of potassium, 5 moles of bromine, so that's 10.
So wait, you double it?
You double it.
Oh,
It's not always double though, it could be triple, right? Could be like, what's the last one? Let's say calcium bromide, CaBr2. So if I put 5 moles of this in the water, that's ionic also, I'm going to end up with 5 moles of calcium and 10 moles of bromine, so 15 total. So you multiply by 3, because there's 3 things in here, right? 1 calcium and 2 bromines, that's 3. So you're either multiplying by 2 or 3 or something like that if it's ionic. If it's covalent, it's just the same amount. All right?
okay.
Questions? Okay, we are done. For the worksheet, just do 1 and 5.